can try your hands on it. So let us move on to, I think that is the last one, application of partial differential equation. Application of partial. I'll read the introduction for you. You write it, then the subsequent ones I will explain. Now listen carefully. In applied mathematics, like engineering, partial differential equation generally arise from the mathematical formation of physical problems, subject to certain conditions called boundary conditions. The differential equation, together with the boundary condition, is what we call the boundary value problem. So all that this introduction is saying is that in applied mathematics, PDE that we have just learned, they normally appear when we are forming physical problems, subject to certain conditions. Certainly there should be conditions in a physical problem. Now, the formation of that differential equation, that partial differential equation, with regard or with respect to the conditions aligned or that will arise, these two come together to form what we call the boundary value problem, in short BVP. So that is what the introduction is about. That's a boundary value problem. It's as a result of having a differential equation together with conditions. Here we are interested in partial differential equation. Okay, and these things normally appear in physical problems. Okay. Well, so in physical problems, because physical problems is made up of two or more dependent variables, that is why it is PD. And there are existing conditions. For every physical problem, there's existing conditions. Okay, these two put together gives what we call a boundary value problem, BVP. Boundary value problem. Now, let us look at how to solve such problems. So B, we're going to use the method of separation of variables. We have method of separation of variables in ordinary. We're also using the same method of separation of variables for the partial. Okay. Now look at something interesting here. Here we're supposed to do a certain assumption. First, you assume that when the problem is given, what you have to do is assume that the dependent is equal to a function of product of independent. I've taught you what dependent is. The dependent is equal to a function of the product of independence. When I say independent, I mean independent variables. Okay, so let's move on and look at an example. Now let us look at an example. Now watch here. Assuming u is a function of xt. I've given you know that this is the dependent and these are the independent. You have done this. These are the dependent and this is the independent. So what happened is that using this method of separation of variables rule, we're going to write that u is equal to x of x times t of t. This is the product and these are the independent. This is capital X is a function of this x. The times capital T is a function of this. This is what it's referring to. Okay, dependent u, product is here of the independent. So that is what it is referring to. And not something. Well, try this. If I'm giving you this, try this and let's see how. Try this and let's see the answer you will get. Okay, but before that, also note that when I write y is the same as y is a function. Well, so after solving this, let us look at this. I said anytime you see y is the same as y is a function of t. Look at this, small letter y, small letter y. So that means that anytime I write this capital letter y is the same as capital x. So anytime I write capital letter x, I can also write it capital letter of x if I want to write it in terms of x. Okay. Anytime you see t prime or t prime of t, it's the same as dt over dt. D of this capital T all over d of this is the same as dt over dt. This t prime is the same as t prime of t. And this is the same as derivative of this t all over the derivative of this t. So note these languages very well. And also the conditions. Also, if I have y of 2 is equal to 3, this statement means that the one in the bracket is an x value, and the one outside is for the y. Y is for the one outside, and x is for the one inside. These are basic things you need to know.